We've given a broad overview of the process of hypothesis testing in statistics. We will be working with specific tests for the remainder of the semester, and we'll be going back through this process in each of these settings. You shouldn't feel that you can conduct any test yourself at this point, but hopefully you have a good picture of the overall process. Try to assess what you most need to work on and focus on that as needed during the coming weeks, returning to this material as needed and asking questions. Before we finish, we have a few important points to mention. First, the cutoff of 5% is not a magic number, and it's open to some interpretation, especially around this value. For example, what's the difference between a p-value of 0.049 and 0.051 in terms of evidence? They're both about the same. I'm not more or less excited about either of these values. The only difference is that one of them lets me legitimately reject the null hypothesis using the 5% cutoff, but both offer very similar evidence. We much prefer to see very small p-values where the conclusion is clear. Next, when writing conclusions to any hypothesis test, especially in this course, it's best to write the conclusion in terms of the alternative hypothesis. Is there or is there not enough evidence that HA is true? You must write your conclusion in context. It must be clear in the words of the problem, as well as using accurate statistical terminology as appropriate. We can never say that we accept the null hypothesis. We can only say that we've failed to disprove it. Be very careful on this point. There's an example illustrating this in the course materials if you need further convincing. Often in journals you will read statements such as the results are statistically significant when the p-value is less than alpha, or the results are not statistically significant when the p-value is greater than alpha. Sometimes statistical significance is qualified based upon the evidence. For example, if the p-value is between 0.001 and 0.01, we could say the result is highly statistically significant. If the p-value is less than 0.001, we could say it's very highly significant. And if it's between 0.05 and 0.10, we sometimes call this marginally significant or trending towards significance. It's important that you find a definition of the p-value that makes sense to you. It's also very important to remember that we begin by assuming the null hypothesis is true in order to find this probability. The p-value is the probability of obtaining results like those of our data, or more extreme, given the null hypothesis is true. In probability notation, we can write P, obtaining results like ours are more extreme, given HO is true. We're asking, assuming the null hypothesis is true, how rare is it to observe something as or more extreme than what I've found in my data? We can also think of the p-value as the probability, assuming the null hypothesis is true, that the result we've seen is solely due to random error or chance. No matter how we look at it, a small probability gives us evidence that the null hypothesis is not true, and thus our alternative hypothesis is true, which is usually what we're hoping to show. We infer that the alternative hypothesis is true only by rejecting the null hypothesis. A statistically significant result is one that has a very low probability of occurring if the null hypothesis is true. Next, we will discuss the difficult concept of errors in power, after which we will begin working some examples ourselves.